Alrighty, so go ahead and put your name and date in your notes and the title, perfect squares / square roots. Alright, well first off, let's get a definition out of the way. What is a perfect square? Perfect square is a number, made by squaring a whole number. And that word squaring just means multiplying by itself. And hopefully you know what a whole number is. Whole number are those numbers 1, 2, 3, 4, so on and so forth. So in order to find some examples of perfect squares, what we had to do was square some whole numbers, which squaring just means to the power of 2. And what to the power of 2 means is just multiply by itself. So we're going to take some whole numbers and multiply them by itself. 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. And these numbers, the outcome from you multiplying these whole numbers by themselves, those are your perfect squares. Okay? So for example, all the numbers in between the numbers that you're saying, those are not perfect squares. For example, like 12. 12 is in between 9 and 16, right? Well, there's no whole number that when you multiply it by itself, you get 12. Because 3 times 3 is 9. 4 times 4 is 16. Well, there's no number in between 3 and 4. No whole number, at least. So there's no whole number that can get us 12 when multiplied by itself. So these are the examples of all your perfect squares. Now, this may look familiar to you from last year, but the difference here in 7th grade is not only do we have to go down to 10 squared, which is 10 times 10, which is 100, we actually have to go all the way to 20 squared. And you have to be able to recognize, if they give you a number, you have to be able to recognize whether it's a perfect square. Now, that means you could memorize them all. That's not very likely. That's pretty hard to do, memorizing 20 perfect squares. Or what you do, let me show you the rest. So here's 11 through 20, if I can get my camera to behave. 11 through 20, 11 squared through 20 squared is what I mean. So all the perfect squares. 11 times 11, down to 20 times 20. So besides just memorizing them all, if you memorize a few, if they give you a number, then you can just start from that number. For example, if you know that 12 times 12 is 144, that's a good one to memorize, by the way, and they give you 121, but you don't have that memorized, well, you could say, well, 144 is more than 121. So I know that if 121 is to be a perfect square, I got to try 11 times 11, because 11 is lower than 12. And then once you did 11 times 11 and you tried that, you'd see that it is 121. And you go, oh, okay, it is a perfect square because a whole number times itself gave you 121. And it works in the opposite direction too. Let's say you memorize that 15 times 15 is 225. And they give you 289. They say, is that a perfect square? Well, you would say 289 is bigger than 225. So I know that the whole number that would multiply by itself to get 289 must be bigger than 15. So you could do 16 times 16, get 256, go, no, not big enough yet. Let me try 17 times 17, and then you would get 289, go, oh, okay. So 289 is a perfect square because a whole number when multiplied by itself gave me 289. Okay, so, oops. There's also something I want to address from yesterday. I meant to actually do it before then, but oops, going a little out of order here. So, from yesterday we talked about adding and subtracting absolute values. Remember, take the absolute value of the first number, bam, take the absolute value of the second number, bam, add or subtract the two numbers together. But what I didn't show you was what just happens when the negative is on the outside of the absolute value. So if you have a negative on the outside of the absolute value, what you have to do is you have to take the absolute value of 3, which is 3, and then bring down that negative. That negative is unaffected by these absolute values. So absolute values can only affect whatever's in between them. So that negative drops down and it turns my positive 3 into a negative 3. So that's my final answer, negative 3. Whereas if the negative's on the inside, well, this is just asking you what's the absolute value of negative 3. Now the absolute value does affect the negative. So that negative 3 becomes positive 3 because absolute value just means, well, what's the distance from 0? Negative 3 is 3 units away from 0. So that's that answer. Now this is where one I really wanted you to get to. What if we have this double negative thing going on? Well, first off, I concentrate on my absolute value. Absolute value of negative 2. So the absolute value affects this negative and the 2. So the absolute value of negative 2 is just positive 2 because it's 2 units away from 0. However, we still haven't dealt with this negative out here. It is unaffected by those absolute values because it's not on the inside. So I just got to bring it down. And look at that. Your final answer is negative 2. Okay. Alright, so the last thing I want to show you is square roots. So using that table that I just showed you, we saw what some of our perfect squares are. Remember, squaring just means you multiply a number by itself. What square rooting is going in the opposite direction. Now we start with a perfect square like 16, and what it's asking us is a question. This symbol, square root, is really asking you a question. What it's asking you to do, it's saying, find a whole number that when multiplied by itself equals 16. That's really what that symbol means. It basically replaces all those words. Find a whole number that when it is multiplied by itself equals 16. So we have to think. 1 times 1, does that equal 16? No, that equals 1. How about 2 times 2? That equals 4. 3 times 3? No, that equals 9. 4 times 4? Oh, wait, 4 times 4 equals 16. So therefore, the square root of 16 is equal to 4. We have found the whole number that when multiplied by itself it equals 16, and the answer was 4. So that's it. It's just going backwards. So how about number 2? Or second example, rather. How about the square root of 144? Well, you could start at 1 and go 1 times 1 is 1, 2 times 2 is 4. Or you could start from something that you already have memorized. Like maybe you have 10 times 10 memorized, which is 100. 100 is a perfect square. So, okay, you say 10 times 10 is 100, so I need to keep going up. How about 11 times 11? Maybe 11 times 11 is equal to 144. So I do 11 times 1. That gives me 11. Which really is 11 times 10. And then I do 11 times 1. Gives me 11 again. But I got to put them in the proper place. Add down, so this 1 comes down, 1 plus 1 is 2, bring this 1 down, 121. So okay, so the square root of 144 can't be 11, because 11 times 11 doesn't equal 144, it equals 121. So I got to keep going up, because 121 isn't quite at 144 yet. So let me try 12 times 12. Okay, 12 times 1 is 12. 12 times 2 is 24. Now I add down. 4, 2 plus 2 is 4. Bring down the 1 and, oh, look at that. 12 times itself, 12 times 12, is 144. So 144 is a perfect square. And the square root of 144 is 12, because it's just going backwards from multiplying it by itself. Really, it's saying find me a whole number that when multiplied by itself gives me 144, and we did that. The answer was 12. Do one more. Try to make it fast. I'm getting kind of long on the video. So number 3, square root of 361. Now this is probably one you don't have memorized, okay? So maybe you have to kind of make some educated guesses. It's like, okay, 144 was 12. Maybe I can like skip some numbers and hope for the best and hope I get pretty close to 361 so I can kind of guesstimate where it's at. Let's try, I don't know, 17? So let's see if 17 multiplied by itself is going to give me 361. So 17 times 1, 17. 17 times 7, well, first off, 10 times 7 is 70. Excuse me, 7 times 7 is 49. That's just a little trick. Do the 10s times the 1 and then the 1s times the 1 and add it all together. And you can put a 0 here if it helps you out. So 0 plus 9. 7 plus 7 is 14, plus 4 is 18, so put the 8 down there, carry the 1, and I get 289. So 17 times 17 still isn't enough. 289. We're still a little bit further away from 361. So you could try 18 times 18. Maybe that would give you 361. I'm going to go ahead and try 19 times 19. Let's see, 19 times 10, or not 1 really, is 19. Just put it in the 10 spot. Then do your 10 times 9. That's 90. And then 9 times 9 is 81. Bring it all down. 0 plus 1 is 1. 9 plus 9, 18. Plus 8, 26. Carry the 2. 2 plus 1 is 3. Would you look at that? So 19 times 19 times itself gave me 361. So that means the square root of 361 is equal to 19. Because 19 multiplied by itself equals 361.